The 100 birds problem originated in China, but spread to India, the Islamic world, and medieval Europe. Most versions involve 3 different types of birds or animals with 3 different costs. In the Islamic and Indian world, versions with 4 types of birds appeared. For example, Abu Kamil, who lived around 900 AD, posed the following: geese cost 4 coins, chickens cost 1, 2 pigeons cost 1, and 10 starlings cost 1 coin, and buy 100 birds for 100 coins. So if we let x, y, z, and w be the number of geese, chickens, pigeons, and starlings, our system is: we want the total number of birds to be 100, and at the cost of 4, 1, 1/2, and 1/10, the total cost should be 100. So if we multiply our second equation by 10 to eliminate the fractions, and then subtract the first, we'll eliminate one variable. And so we want to find integer solutions to. Since the greatest common divisor of 9 and 4 is 1, we'll group this second pair of terms and introduce a new variable t equal to 9y plus 4z and find integer solutions to, which we can solve as, or letting x equal to s. And so that gives us expressions for x and t. We let t equal 9y plus 4z, so now we have 9y plus 4z equal our t value, and this corresponds to the system of congruences, which we can solve. And substituting these back into our equation gives us a relationship between our new parameters u and v, which will solve for u. And so we can express y in terms of s and v. For our fourth variable, we have the total number of birds as 100, and so w is going to be so we can find the region giving us positive values for x, y, z, and w, but we won't, because that's a lot of work. Note that in order for w to be positive, v must be negative, and so we note that one solution occurs if s is 13, v is negative 8, which gives us an even more complicated problem appeared in the work of Mahavira, an Indian mathematician living about 50 years before Abu Kamil. 3 coins buy 5 pigeons, 5 coins buy 7 cranes, 7 coins buy 9 swans, and 9 coins buy 3 peacocks, but again buy 100 birds for 100 coins. So if we let x, y, z, and w be the number of pigeons, cranes, swans, and peacocks, our system will be 100 birds, cost 100 coins. So as before, we can eliminate the fractions in the second equation by multiplying through by a common denominator. And if we subtract 189 times the first equation, we'll eliminate x. And there's a common factor of 4 we can remove. So finding integer solutions to this means finding integer solutions to this equation. Note there's a common factor of 9 in the first and third terms, so let's group those to get. And using v equals y plus 21w, we have a linear equation with 2 variables, and since the greatest common divisor of our coefficients is 1, this has solutions corresponding to solutions to the congruences, which will be, and so v is 14s, z is 9t, and substituting those into our equation gives us t in terms of s. Now, it doesn't matter whether we solve for s or t, But note that we'll be working with v later on. So let's go ahead and solve for t. That allows us to write our solutions this way. And so v has a simpler expression. Now remember, v was y plus 21w, so we have, where our greatest common divisor of our coefficients is 1, so we know there are solutions corresponding to the congruences. And so again, we can solve these to get. And again, substituting these into our equation. And again, it makes no difference whether we solve for r or for u, but remember, we do want the number of birds to be non-negative, and w is actually a number of birds. So let's keep u and solve for r. And so we have our expressions for y and w. And finally, since there's a total of 100 birds, we can substitute in our values and find an expression for x. In order for x, y, z, and w to be non-negative, we'll require all of these to be greater than or equal to 0, and we'd find a region corresponding to the non-negative solutions. We'll let you do that. And we'll just note there are a number of non-negative solutions, such as s equals 21, u equals 13, and in that case, we get the solution, which you can verify is 100 birds costing 100 coins.